Interesting thing about u substitution, we don't have to plug back in u. We don't have to substitute it back in if we're using a definite integral. And I'm actually going to show you both ways on this first example. Then I'm going to do it the way I prefer after that on a couple more examples in the video. And then I think I'm going to write out the solutions to the others. So I don't have a really lengthy video like I did in this last one. But I did, I wanted to make sure it's clear some of the details there on this one. But I think by now you could probably read along as you go through these. So for this first one, like I said, I'm going to use both methods. And we're gonna compare the two. They're both the same. I know there's probably one you prefer, but there is one, this first method, you have to know for sure how to do it this way. So both methods are acceptable. So on this first one, u is going to be the same thing on both of these. So I'm just going to put u right here. (2x squared), 1 plus 2x squared, and then so du is going to be 4x times dx. So then you're going to have du over 4x equals dx. All right, so that's going to be our u substitution. That's the same on both of these, so I figured we'll put that there in the middle. Okay, so for this first one, I have an x on the top over, and I'm going to substitute in the u. So that's going to be u squared times du is going to be du, or dx, which is du over 4x. Okay, so the x's cancel. Now, notice I erased the bounds actually that I had there. So this first method, what we're going to do is we're going to change the bounds. So I'm going to plug the 0 in here. And 1 plus 2 times 0 squared is just going to be 1. So once again, I plugged it in to this, into u. And plug in the 2. 1 plus 2 times 2 squared. 2 times 2 squared is going to be 8 plus 1 is 9. So just change the bounds on these. Okay, give us a little bit more room here. All right, so let's clean this up a bit. So the x's will cancel out. The 1 over 4 will come out to the front though, since it's a constant. And then we can bring that u squared up to the top as u to the negative 2. So this is method 1. We change the bounds. Method 2, you don't change the bounds. So that's going to be 1 over 4 times u to the negative 1 over negative 1 from 1 to 9. Clean that up, so the negative 1 just becomes a negative. So we have negative 1 over 4u from 1 to 9. Okay, so now what I'm going to do is I'm going to plug in. For u, I'm going to plug in the 9. And then I'm going to plug in the 1. And actually, I should probably do those in a different color, just to show you that it's the same thing in the next example. So that's going to be negative 1 over 36. And I'm going to have to get a common denominator. So that's going to require me to multiply this one by 9 over 9, because it's going to be 4 on the bottom right. So plus 9 over 36, which is 6 over 36, which is 1 over 6. So 1/6 is the answer. Seems pretty lengthy, but it's not too bad. So let's look at the second method. I'll zoom out and then we can kind of take a look at the comparison between the two. So I'm going to go through it a little bit faster, but we're not going to change the bounds. So we're going to do it just like we would have in that classic one. So for the method 2, we're going to have the integral from 0 to 2, and it's going to be x over u squared du over 4x. So we kind of already know these details. So then we bring the 1/4 out to the front. I didn't change the bounds. That's really the only change here, 0 to 2. Then we'll have u to the -2 du. And then I'll go ahead and be nice if I was kind of on the same level as this one over here, so we can see the side-by-side comparison. Then this equals 1 over 4 u to the -1 over -1 from 0 to 2. But on this one, we're going to plug u back in. That's what we're going to do here. Since we didn't change the bounds, we're going to plug u back in. Notice over here, when I changed the bounds, I kept everything as terms of u. And it ends up looking very simple. But over here, since I kept the bounds the same, I'm going to have to plug our u back in. And what was u to begin with? 1 plus 2x squared. You can already see how this looks a little more difficult, right? Or maybe not more difficult, but just ends up more work. So we'll have 1 over, this will become 1 plus 2x, or no, 2 times 2 squared. Minus -1 over 4 times 1 plus 2 times 0 squared. Now I want you to pay attention to something here. What's 1 plus 2 times 2 squared? It's 9. What's 1 plus 2 times 0 squared? It's 1. We had already done that before, right? In the beginning when we did that over here, when we plugged the 0 in here and the 2 in here, that's what our new bounds are. So we're actually in the exact same situation over here when we simplify that. It just looks a lot more complex. So this becomes -3 over 36. Plus 9 over 36, and you can already see that that's going to give us the exact same answer. So, you know, you can go with what you prefer, but you do have to know how to do it this way, because sometimes some of the questions you may get may be a multiple choice, and this is what they're asking for, in which case you have to know how to change your bounds. So the method I'm going to be rolling with on all these is the changing bounds method. So make sure that you are going to go with this method here. I'm gonna put a little star there. And here I'll put a little X. So we're gonna go with method 1 on all these, all right? So let me go ahead, I'll just work straight down through these 2 examples. And then I might do these solutions later on outside the video. Just kind of with the step-by-step details. I know these videos are long because these are kind of long problems. So here, we're going to make our u to be the cosine of x. That way we'll have u to the 3rd power. So then du is negative sine of x dx. So then divide that over, negative du over sine of x. It's going to be our dx, right? So let's substitute that in. So that's u cubed, and then times dx, in this case, is going to be negative du over sine of x. So we can see that sine of x cancels out nicely. Should have seen that from the beginning, right? Derivative of cosine will cancel out there. Now let's change the bounds. So if we plug a 0 into cosine, good old unit circle. 0 into cosine right here is 1. Cosine of 0 is 1. And then pi over 3 occurs right here. Oops, that's pi over 6. Pi over 3 over right here. So we're closer to the y-axis, so our x value will be 1/2. Remember which axis you're closer to, that coordinate's going to be square root of 3 over 2, whether positive or negative, and the other one will be 1/2. So we're further from the x-axis, so the x is 1/2. That's another way to think about that. So let me put the 1/2 for our bound here. Simplify this a bit so that negative comes out to the front. Signs cancel out. We have u cubed from 1 to a half du. Just do the antiderivative of that. Negative u to the 4th over 4 from 1 to a half. Plug in the half. So that's going to be, 2 to the 4th is 16 times 4 is 32. One to the 4th. Which is really just 8 over 32 because we're going to have to get a common denominator. And there's the answer. So it's not too bad. It actually made things a little bit easier, right? To keep things in terms of u. Don't have to plug it back in with definite integrals only, remember? All right, here we're going to make our u to be 1 plus e to the x. We talked about this in the last video, when to do 1 plus e to the x and when to do e to the x and do the whole change. Remember, if it was a 2x here, we'd be stuck separating that out to e to the x squared and using arctangent. But here, if you just think about it, I don't know why I put u plus. If you say that u equals 1 plus e to the x, when we do du, it's going to be e to the x dx. You can kind of visualize this already, which means du over e to the x equals dx. So that just means that this is going in here, and the e to the x on the bottom will cancel with that e to the x on the top. And the u goes in on the bottom. And we'll have times du over e to the x. And the e to the x is there, you can see will cancel. But we have this natural log of 2 and natural log of 8 to deal with. So let's think about this for a bit. So let me do that in red. So 1 plus e to the natural log of 2. Remember, e and natural log cancel out. So that's really going to be 1 plus 2, which is 3. Similarly, 1 plus e to the natural log of 8 is going to be 1 plus 8, which is 9. Remember, e and natural log will just cancel each other out. So simplify this integral a bit. 3 to 9. 1 over u du. So now it matches up with that formula. So natural log of u from 3 to 9. So then this becomes natural log of 9. We don't need the absolute value anymore because it's a positive number, minus natural log of 3. And remember, from the quotient rule of logarithms, that means we can combine those two to do 9 divided by 3, which is natural log of 3. Good chance if you run into this situation, they're going to do that. So you got to know those basic properties of logs. If not, you can go back to the notes, I believe. I don't have those notes on those. I need to put some notes on that, though. Maybe I'll put it under review. All right, and that's definite integrals using u substitution.